Hello all, this is K. Jantar and today I'm here to present regarding sorting techniques. There are various sorting techniques like bubble sort, insertion sort, selection sort, etc. and etc. So today we will have a deep debrief on the topics. Along with it, we will also see the characteristics of the sorting algorithms and the complexity and the of these algorithms along with the application of these sortings. So the first and foremost, the big question rises: what is sorting? Sorting is basically a process of rearranging the elements of an array or a list in a specific order. Let's take an example that we have given a array in which the elements goes like 20, 10, 30, 40 and 50. So when it will be sorted, it will be sorted in the ascending order like 10, 20, 30, 40 and 50. If the order specified is descending, then it will be like 50, 40, 30, 20 and 10. How it is achieved? It is achieved using a comparison operator to determine the new order of elements. So basically, sorting is a fundamental operation in computer science and is used in various applications such as searching, data management, database optimization, etc., etc., etc. So the first type of algorithm is bubble sort. This is the most simplest sorting algorithm among all the algorithms available for sorting. What is the working mechanism? It repeatedly checks the adjacent elements and swap if they are in the wrong order. Basically, it does sorting in swapping manner. It is not suitable for the large datasets because it has a high time complexity. The code is given below, and you can have a look on that code. This is the code that is required for bubble sort. Let's move on. The second thing is selection sort. This algorithm divides the array into a sorted and unsorted part. So basically the array is divided into two parts and it follows the approach of divide and conquer. So there are two arrays in which the sorted elements are in one array, which is called a sorted part, and unsorted elements are in another array, which is called as unsorted part. It repeatedly selects the minimum element from the unsorted part and moves it to the sorted part. So this is how the selection sort works like. And again, the code is given below. You can have a look and perform selection sort in your systems. Third, we have insertion sort. So this algorithm also somewhere similar the way you play sort playing cards in your hand. It builds the final sorted array one item at a time. The code is given below. Fourth, we have merge sort. So this is based on divide and conquer algorithm. It divides the array into two halves and sorts them and then merges them back together. Let's take an example. You have an array of 6 elements like 60, 30, 20, 10, 40, 50. So it will divide them into 3 and 3 like 60, 10, 20 in one part and other 3 elements in the other part, and then again it will divide the 60, 10, 20 into another part and that another part into a sub part. So finally when all the array is divided, then it will start sorting and merge them together. This is how the merge sort exactly works like. So the code for the merge sort is given below. It's a pretty lengthier code, but the advantage for the merge sort is it has a less time complexity. It might feel complex while typing or writing the code, but for the computer system, the time complexity is very minimal. And the final sorting technique for today's video is quick sort. This is also another divide and conquer algorithm. It is basically on the principles of pivot element and partitions the array around the pivot element. So the code for the quick sort is given here. So we will basically selecting the pivot element. It might be the leftmost element or the middlemost element or the rightmost element. It's completely depends on your wish. If you want to take the greater element as the pivot element, if you want to take lesser, you are. So that's what quicksort basically works. And the final things today for the video is characteristics of sorting algorithm. So what are the characteristics of sorting algorithm? Sorting algorithm can be characterized by their time complexity, space complexity, stability, and whether they are in place or not. For example, merge sort has a time complexity of O n log n and is stable, while quicksort has an average time complexity of O n log n but it is not stable. So finally, the applications of sorting, it is used in searching algorithms. Sorting is often a crucial step in searching algorithms like binary search. For binary search, the array must be sorted. Otherwise, the searching can't take place. So in that scenario, the sorting algorithms comes into the play. And the second thing is data management. Sorting there makes it makes too easier to search, retrieve, and analyze. If the data is not sorted, it will be very much difficult to search and retrieve. And database optimization is the other application. Sorting the data in the database improves the query performance. And finally, machine learning. Sorting is used to prepare data for the training machine learning models. So thank you.